Good afternoon, everyone. Dear authors and invited guests, welcome to the technical session 8C. Myself, Siddhi Auti, and this session will be moderated by me. On behalf of the Global Knowledge Research Foundation and GR Scholastics LLP, it is my great pleasure to welcome you all to the 10th International Conference on Information and Communication Technology for Competitive Strategies, that is ICTCS 2025. The 10th edition of the conference is being held in a hybrid mode. The physical event was held yesterday in Jaipur, and the virtual event is being held via Zoom meeting on 16th and 17th December. I hope you all will enjoy this knowledgeable and interactive session. In this session, in total, we will be having 10 presentations. Each presenter will be given a time span of 10 minutes, 8 minutes for the presentation, and 2 minutes for question and answers. So, after 9 minutes, I will be raising a gentle reminder. Also, there is another request to all the participants that you all stay connected with us till the closing remarks. And if you face any difficulty or any issue, you can write it to me in the chat box. Now, just before we start with this session, I would like to introduce you all to today's session chair, Professor Kalyani Ghuge. Uh, Kalyani ma'am is an assistant professor in the Department of Computer Science and Engineering, Artificial Intelligence and Machine Learning at Vishwakarma Institute of Technology, Pune. With 10 years of academic experience, her areas of specialization include medical imaging, deep learning, and machine learning. She is an active professional member of the International Association of Engineers, IAENG, and serves as a Board of Studies BOS member, contributing to curriculum development and academic advancement in her field. Welcome, ma'am. Thank you for chairing this session.
Yeah, thank you. Thank you for introduction. Thank you. I welcome
Now
all
we
the
will go on
participants.
to
Yes.
the very first presenter. So, where the first presenter is Arif Khan from Jamia Hamdard University, and the paper title is A Hybrid AES S-Box and Reduced Round Chacha 20 Framework for Secure Web-Based Image Encryption. So, if you're there in the meeting, please start with your presentation. I don't think he has joined the meeting yet, so we will move on to someone who is already present in the meeting. Okay, so Relly Bohil uh, Pata from Central University of Technology, South Africa, and the paper title is Developing a Machine Learning Algorithm to Ensure Geometric Fidelity in Laser Powder Based Fusion Platinum Products. So you're there in the meeting. Would you be able to present?
Yes, thank you.
Sorry for the mispronunciation. You can
No
start with your
problem.
presentation.
All right. Um,
I've stopped sharing my screen now. Now you can share.
okay. Are you able to see it?
Yes.
All right. Um, good morning, everyone. Well, it's morning from my side. My name is Hile. I'm here to present on machine learning for geometrical fidelity in LPBF platinum products. So additive manufacturing is commonly known as 3D printing. It's a method where objects are created layer by layer from a digital model. It encompasses many materials such as metals, polymers, ceramics. Additive manufacturing applications include medical, aerospace, as well as the automotive, industrial manufacturing. So laser powder bed fusion is widely used um, as a widely used additive manufacturing process that allows for complex structures to be manufactured with precision with the use of with the use of a laser that scans over a powder bed to form a 3D object. So the challenges that we have with laser powder bed fusion are material selection, process reliability, process repeatability, as well as costs. So conventional methods used to solve these challenges are usually through lab experiments, which can be time consuming and expensive. This becomes a challenge when utilizing, can I hide this? Okay, this becomes a challenge when utilizing high value materials such as platinum. So LPBF paired up with machine learning can help us with accelerating production, improving quality and consistency of parts, can make platinum additive manufacturing more affordable for more industries. Problem statement that we have is that the adoption of machine learning in additive manufacturing for platinum remains limited despite its potential to address key challenges such as geometric fidelity and material waste. The geometrical consistency of a 3D printed part must align perfectly with the intended design to ensure the desired functionality. Given the high cost and material constraints of platinum, further research is needed to integrate machine learning into additive manufacturing processes in order to optimize the print quality and reduce the amount of expensive experimental iterations required. So our aim for this project is for us to use machine learning in order to develop models that would be trained with using existing data of platinum products to accurately predict and to predict the correct reverse compensation algorithm that could be applied to a CAD file in order to ensure reliability as well as repeatability of the quality of LPBF platinum products. And then our objectives here are to study the geometry and identify geometrical variations of LPBF platinum products from available CAD files, to collect sufficient data in order to allow for model development, to train the model based on existing data in order to predict geometric fidelity, to use the trained model to accurately determine the right compensation algorithm in order to ensure reliability and repeatability of the quality of the platinum products. And then the last one is to establish the validity and accuracy of the model before the commencement of mass production of platinum products. So machine learning is a subset of artificial intelligence that is able to learn from data and make decisions or predictions based on the data. So machine learning in additive manufacturing can also help us with process and design optimization, defect detection, quality prediction, real-time monitoring, as well as quality control and sustainable manufacturing. So the main categories that we have in machine learning algorithms are supervised, unsupervised, as well as reinforcement learning. Supervised learning models are trained using labeled data where both the input and output data are analyzed, and the algorithm is able to learn relationships between the data. Whereas under supervised learning, there are classification and regression algorithms. With classification algorithms, these predict discrete and categorical labels. The common classification algorithms include logistic regression, decision trees, random forest, SVMs, KNNs, naive Bayes, as well as neural networks. And then regression algorithms, they predict continuous numerical values where the goal is to estimate a real valued output based on input features. So those are some of our common regression algorithms, which are linear, polynomial, decision tree, random forest, as well as SVRs. So my methodology, or our methodology for this project starts with data collection. So this data could be CAD models, printing parameters, printing powder properties, and data from actual real prints. And following that will be data cleaning. The data collected will go through pre-processing to make sure that it is in a suitable format. And this will also help us improve with model accuracy, prevent errors, as well as save time. And then following that will be feature extraction. After that, there'll be model selection. So because machine learning models differ in functions and capabilities based on the application, selecting the correct one is essential to achieving accurate results. So for this project, we are leaning towards classification algorithms where we will be classifying a part as having geometric fidelity that is either acceptable or not acceptable, or that has a high, medium, or a low geometric accuracy. So after that, there'll be training and testing of the model. The model will be trained by feeding the data into a machine learning algorithm in a modeling software. The data will then be split into an 80-20 ratio for training as well as for testing. So after that, there'll be model evaluation, um, where we will utilize multiple matrices, evaluation matrices such as the F1 score, precision recall, as well as the accuracy. And then
Hello,
after that, we will.
ma'am. Sorry for the interruption, but we are past the presentation time. Can you please get to the conclusion?
Okay, sorry. So, together with conclusion, some limitations that we have are that we'll be starting off with titanium due to its availability and cost, as well as our shapes will be simplified. So we won't do any complex shapes yet. So this study has highlighted the potential of integrating machine learning with LPBF to address these challenges of achieving geometric fidelity in platinum-based manufacturing. So by leveraging data-driven approaches to use machine learning, the use of machine learning can aid in predicting geometric fidelity, enable reverse compensation strategies, as well as optimize process parameters in advance, thereby reducing defects, minimizing material waste, and enhancing overall product quality. In addition to enhancing the geometric accuracy of platinum products, this integration supports cost efficiency, enables scalable production, and promotes wider adoption of additive manufacturing in sectors where platinum is essential, such as the aerospace, medical, automotive, and jewelry industries. And that's some of our future work. Thank you.
Thank you. It's really very nice presentation. Could you please let me know which algorithm is best for suitable for your data set?
Um, it will depend because we are going to use a lot of numbers, right?
Mm,
Um, and images possibly. At this stage,
okay.
we don't have a set algorithm that we have. So it could be a combination of both classification as well as regression algorithms.
Okay, so if you are saying for the data collection, right? So what type of the data that you have collected?
There is parameters, laser parameters, um, the material properties, um, yeah,
It's a
just
it's
laser
a
parameters.
okay.
Yes.
It's real-time data.
No, 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 no. It's not real-time data. It's not
Okay.
real-time data.
Yeah.
Yes.
Okay. Okay. So last question. What is the degree of accuracy?
The degree of
Accuracy. You mentioned in your PPT degree of accuracy that you are considering as a majors, right?
as a sorry, I can't.
Majors, performance major. You have considered that degree of accuracy.
Yes. We will look into that with the evaluation metrics. Those will tell us if the geometric fidelity is it high, medium, or is it a low geometric accuracy? Yeah.
So it is different than your normal accuracy and degree of
Sorry.
accuracy are both are different.
Yeah.
Accuracy, normal major is accuracy, right? Am I audible?
Okay. A little bit. I can't hear anything.
Yeah. So my question is that there is a accuracy is one of the major, and you mentioned a degree of accuracy. So is there any difference?
Not as far as I know, because I was working with my supervisor. I think he's the one who knows a lot of the machine learning stuff.
Oh,
So I know
okay.
that we'll be using the evaluation metrics, and then we'll find which one is more accurate in predicting the fidelity.
Okay, fine. Thank you. That's all from my side, Siddhi. Thank you.
Thank you, ma'am. Now we will go on to the next presenter. So the next presenter is Poonam Prakash Patil from Savitribai Phule Pune University, and the paper title is Analysis of Usage Patterns of Different UPI Payment Apps. Ma'am, you have joined the meet. Would you like to start with your presentation?
Yes, ma'am.
Okay. Stopped sharing my screen now. You can share.
Yes, ma'am.
Previous presentation.
Yes, I've removed it. Now you will be able to share.
Yes, ma'am. My presentation is visible to you.
Yes.
Yes. Good afternoon, ma'am. Today I present my topic, that is analysis of usage pattern of different UPI payments apps. So, in this research, the background is the context we called, that is the after uh, post demonetization, there is all users are shifted to the digital payment way. So most probably the users like the UPI payments gateway. Parallelly, we studied with the different comparing apps like a UPI banks app, then online uh, payment system. But we found that UPI is the most popular payment gateway for among the users. And there is we again studied or we compare the UPI enable safe, secure, and fast transaction. So these are the features which are provided by the UPI payment method. So that's why the users are like that. Then if we found financial inclusion, so there is the millions of transaction process per second in a day. So there is the new technology which is emerging in India, and it contributes the more GDP in our economical growth. And for this study, I collect the 139 responses from the different users, and I apply the exploratory methodology for this study. Then these are the research objectives for this paper. First is to compare the top UPI applications in India, including the bank-specific UPI platform, comparative with Google Pay, Phone Pay, and Paytm. These are the UPI payment gateways. And second one, to access the market share, security, transactional speed, functionality, and user interaction. So here, these are the features we consider here. Then third one, to study user behavior by breaking into demographics and educational background. Fourth one, to highlight the technology advancement, client detection tactics, and regulatory compliance of the bank affiliated and non-bank UPI apps. And fifth one, to make a recommendation for enhancing the platform-wide adaptation with a security and easy to use for the user. So research, I already tell about this research is based upon the exploratory research. So for that, I collect the primary data in the form of 139 responses, and secondary data I referred from some relevant papers, research papers from websites and journal. Then I do the analysis in the form of data tables, graphs, and statistical tests. So first one in this is a gender based. So in this study, I found that the most probably the male users are the prefer the UPI payment than the female. So here we get the count differentiation that male usage is 60% and female usage is 39.57. So here, but yeah, I tested this, then the value approx is the same. So there is a no significance difference between this gender. Then second one is the educational background impact. So mostly we found that if the users are the IT background, means there is a technical literacy is there, then they are preferred to use the UPI payment method. So here we get the percentage that is 76.98 for the IT background, and for non-IT background we get 23%. Then, if we compare all the payment methods with the UPI apps, so here preferences from the users we get 88.49%, and for the rest of the card online card payments, then cash and other whatever the platforms available in market. So comparatively, the UPI get the more percentage than others. Then here are the some scenario we take the number of UPI apps. So users mostly prefer the different UPI apps. So based on that, also we studied that they are using single app or multiple apps in their for their payment transactions. So single app users are 37% from this 139 responses. Then two apps users are 39, and three apps are 16%, and more than three apps if they are using, then it is a 8%. So mostly they are using the single and two apps for their transaction. Then based upon this UPI study, we found that there is a frequency of the transaction. So mostly 3-4 times we do the transaction. So here we found that users prefer the 3-4 time transaction using the UPI payment way, and other 1-3 times or 5-6 times we get the less percentage. Then this is the usage pattern of the UPI payment way. So here we present the heat map presentation for the different time they are using the UPI apps. So here this is the mostly we see that the phone pay and GPay are the competitive to each other. So 74 users use the phone pay, while 53 users use the GPay. So they are the mostly use the no preferences while they are doing the transaction. Then these are the different times, that is daytime, morning time and evening. So every time we see that only the competition in both phone pay and GPay. So they are the parallelly used by the users. Then this is the again we take the scenario that is the when the mostly users use, means what time or what day they are using the UPI payment gateway. So here we consider the weekdays and weekends. So most
Ma'am,
probably the both will.
sorry for the interruption, but we are past the presentation time. Could you please get to the conclusion?
Yes, yes. So these are the app features for every UPI payment: fast QR scanning, easy to use, fast responsive, most secure, and most rewarded. So here we find out the some key points, that is there is the gap exists between the gender, that is female and male. So we provide the literacy to the gender, so we can increase the count of the usage of the UPI. Then take literacy also we conduct, so adaptation of this digital payment we can improve. So it is contribute to Indian economy. Then third one is a UPI dominates payment method. So there are the different digital platforms are available, but UPI is the most dominant payment gateway system in the market. And using this study, we say that GPay leads to the all categories. That's why it grows rapidly nowadays. And these are some recommendations from my study. That is the we can bridge the gap between the both gender and gender gap, and we can conduct some awareness campaign, and we can summarize this gap. Then promote we using this campaign we can promote the digital literacy for the non IT users. Then again which are the parallelly for the digital payment gateways like a Paytm and back UPI, they also get some features and advance their features, and improve the features in that UPI app, so easily users can use these different UPI apps. Then implement robust and security fraud preventions, and improve the functionality of the UPI payment methods. So these are the future enhancements. Personalized financial ecosystem for the users, then intelligent fraud detections and security using the AI and ML. Then we can third one, proactive financial management we can do using this. Then enhances user experiences and retention. And conclusion of this study is UPI payments are rapidly transforming the India's digital landscape. So GPI is the more powerful fintech in our society. So this is the study of this research. We conclude here. Thank you, ma'am.
Okay, thank you for presentation. So I just want to understand the transaction frequency pattern that you have included. And one more thing related to the data that you taken from the Kaggle.
No, ma'am. I actually flowed the Google form, and that way I take the data.
Okay. So don't you think then if you have the data that is not uh, worldwide data or it is not realistic data, right? It is related to the one region only. What do you think?
Yes, ma'am. Based upon the experience of the users, I take this analysis.
Okay. So if I move towards your transaction frequency pattern, so in that case, have you deal with the small retail frequency or the food delivery transport or likewise the other thing?
No, madam. This is the user perspective. It is not a perspective of the
Yes,
retail
exactly.
consumers. Yes.
No, no, no. From the user perspective itself only. So you have to give the patterns to the users. So for 50 transactions that you have dealing with a small retail payment,
Uh,
30 transactions you have food delivery payment. So that is
okay.
also the categorization you can have in that, right?
Okay. Okay, ma'am. Okay.
And last question, that is a time-based value pattern that you have. That is
Uh,
this one is peak hour and off-peak hour,
yes.
right?
Yes. Yes, ma'am.
Okay. And again, low value, medium value, and high value. How you decide the transaction pattern in that case? Am I audible?
Yes, ma'am. Yes, ma'am.
So I want to understand you have low value, medium value, and high value transaction pattern, right? Value
Okay.
pattern
Uh,
you mentioned in your PPT. So how you decided that? Have you have any threshold or what patterns that you have understand? So you consider this is high value, this is low value.
So I just based upon whatever the data I collected, based upon that, I just give this visualization. And if you expect this one, then yes, it is maybe my next version of this paper. So I do the all statistical parts and implement this kind of central tendency in my research, and maybe next version I will elaborate.
Right. Thank you. Thank
Yeah,
you. That's all
thank,
from my side. Yeah.
yeah,
Over to you,
thank you, ma'am.
Siddhi.
The next presenter is Sayyed Abrar from Amrita Vishwa Vidyapeetham. And the paper title is Big Data Architecture for Multimodal Surgical Skill Classification. Sir, if you're there in the meeting, please give a response and start with your
Hello,
presentation.
am I audible?
Yes.
Just a moment, I'll share my screen. Can you see my screen?
Yes.
Shall I start, ma'am?
Yes, sir. You can start.
Good morning, everyone. Today, I'll be presenting our work titled Big Data Architecture for Multimodal Surgical Skill Classification. Like in simple terms, if I tell this, our work focuses on how we can automatically and objectively assesses the surgical skills using the data which we got. So here our two main source of data is EEG, which will be telling us about the surgeon's brain activity, and eye gaze data, another one modality, which will tell us where the surgeon is looking and how focused they are. So our motive was, instead of building only a machine learning model, why couldn't we design a fully distributed system which can handle a large and fast data and gives us a real-time feedback. So this is what the work is done, like a distributed AI framework which will aim at improving the cognitive skill assessment in a robot assisted surgery. So um, let us imagine, like, first we have a surgeon who is performing a surgical task on a simulator. So this is where all the data for our project is being generated using DaVinci simulator. And next we use sensors, mainly EEG and eye gaze, and which will capture the brain activity and visual attentions. These sensors generate continuous and high frequency data. So because of this, we needed a distributed system which can collect and synchronize and process data from multiple sources in real time. And finally, that will give the process data for a skill assessment, where our algorithm objectively evaluate the surgeon's skill level and the performance level. So here it is handling data at scale in real time and in a reliable way also. So the next is why surgical skill assessment is still a problem. So first, most assessment are subjective. They only depend heavily on the expert's observation, which will be and can be varied from one evaluator to another. Second, the feedback given to the trainees are often inconsistent, and they are not scalable too. So let us, if there are number of trainees are increasing, and it will become very hard to give the same feedback to everyone, right? Like to give feedback of each and every person's skill at in a real time also, and to give feedback for more number of trainees will be also hard. And modern surgical simulators generate a huge amount of data also, such as brain signals, eye movements, and system logs to evaluate their performance. So, however, most of this data is not fully used for evaluation. So, even though we have a rich data available, we just need and rely on manual adjustments, which limits accuracy and fairness. So this gap between available data and how actually it is getting used is one of the main motivations of our work. The next is why the it is also includes a literature survey why current approaches does not scale in this thing. So firstly, many system focuses on only one modality, either EEG or eye gaze. And when we do this, we miss the interaction between how the brain thinks and where the eye look and how actions are performed. And basically surgical skills is a combination of all these, right? So single modality systems gives only a partial view, and we can't depend on that results whole. And secondly, the most pipelines are offline and centralized, which means it is processed after the task is finished, so no real-time feedback is given. And because of this, they are not useful during the training session also. Thirdly, they are model centric, which means they focus only on accuracy and but not in the deployment. When the when the data size increases or multiple users are involved, these systems break under the load. So this limits the scalability, transparency, and real world integration parts of the data. Next is how we reframe this surgical skill assessment. So based on the limitations we just discussed, we reframed how surgical skill skills should be viewed. So surgical skills, basically it is not a single signal or a single action. It is a multimodal cognitive phenomenon, which means it involves how the brain process information, where the surgeon looks, and how both together influence performance. So this is why we fuse EEG and eye gaze data, which will make us understand the cognitive load and mental effort of each surgeon. So, and since these signals are highly frequenced and continuous, we are using a distributed pre-processing system to scale them. And finally, we design a system which will support real-time inference and feedback for the essential surgical training. So here you can see our architecture diagram. Like I'll explain it from the left to right. On the left side, we have a distributed node cluster, a multiple worker node, which will process data in parallel. So that will allow the system to access and scale the data when the volume increases. These nodes will coordinate through a middleware layer, which it will where it will handle task scheduling, load balancing, and fault tolerance also. So when the raw data coming from the EEG and eye gaze sensors is ingested, and it will be stored and shared in the databases. Like from there, the data will move into the feature extraction layer. The EEG and eye gaze data will be pre-processed, and these features will be passed to the machine learning layer also, where we perform skill classification and performance related score predictions also. So these prediction results are streamed in real time using live inference stream tools. And finally, we have the monitored and dashboards using Grafana and Streamlight interfaces, which will show the live trends and a deeper data analysis. So moving to the methodology part, we have distributed architecture for multimodal skill assessments. So we start with EEG and eye gaze acquisition data from the surgeon during the task. So let us take, I'm taking one surgeon's data. Since both the signals are highly frequenced and the performance, we perform a distributed pre-processing using the tool PySpark and Dask, which will allow multiple nodes to process data in parallel, and that will avoid the bottlenecks happening in the large when we load the large data. And then we apply feature reduction and encoding part to remove the redundancy and keep only the meaningful information. That is basically the feature reduction part. And we reduce the features that then we'll use it for the skill classification and performance scores also. So here the prediction outputs are logged in real time using the Redis platform, where we support, which will support because Redis will support the low latency data streaming. And finally, we will view through the Grafana for live monitoring and this thing, skill classifications. So next is like extracting the cognitive and visual skills. Here we have a, methodology diagram. Starting with EEG, we have the raw, we use the empirical mode decomposition, where we'll break the signal
Hello.
into simpler components.
Sir, sorry for the interruption, but we are past the presentation time.
Okay. I'm so sorry.
Can you please get to the conclusion part?
Yeah, ma'am. Can I go to the results section?
Yes, just conclude it within a minute.
Okay. Um, Yes, ma'am. So I'll conclude it like in terms of the skill classification. So we had a mix of simple and tree-based models. We evaluated KNN, random forest, XGBoost, and linear models to cover different learning behaviors. So KNN, it trialed with similar past trails, and leave one subject out validation. KNN learned neighborhood level similarities. Next, the random forest was chosen to handle nonlinear relationships between the noisy features which are coming from the EEG and iGaze data. And next, XGBoost was included because it is a strong ensemble model which will capture complex features and interactions from the nonlinear data. However, with our compact feature set of 40 features, which we reduced from 16,000 to 40 features, it advantages over random forest was limited. So, to summarize, KNN performed the best because the skill patterns are similarity driven, which will generalize well under subject independent evaluations also. And it's also a tree based model, which will perform well but more sensitive to subjected bias. So these results were proven, which will reduce interpretable feature space combining with neighborhood based learning. So KNN performed overall good accuracy. So to conclude our work, uh, we presented a scalable distributed framework for surgical skill assessment using multimodal physiological signals by combining EEG and eye gaze data. So our framework achieves a reliable skill classification and accurate performance score prediction even under subject independent evaluations. So most importantly, we also did it in a real-time inference and visualized using Streamlit interface, which is making the system practical and deployable for surgical training environments. Thank you for your time.
Uh, Thank you. It's really a good topic. First of all, thing I want to understand related to your ECG data and eye gaze data. What exactly it includes and how exactly you are enclave with the surgical, what you can say, surgical skill classification.
Like how the EEG and eye gaze data are used right now.
Yes, right. I want to understand the importance of that data because you are having a surgical skill classification and what type of the classes that you have in that particular skills.
Ma'am, we have classes based on the skill performance, like novice,
Okay.
intermediate, and expert. These three are our labels, if I basically tell. So first in the EEG
Okay.
data, we have
One moment
multi-channel
again.
brain signals, like 128 channels, and
Okay.
now in eye gaze data, we have gaze coordinates on this, which is recorded from the screen. So finally, together it will completely picturize like a surgical skill by performing a task. In the data set, it will be like one task with respect to its EEG and ECG features will be there. So we got approximately 16,400 features, where I mentioned before, we used a distributed AI pipeline and we reduced into 40 useful, meaningful features. So that is what fed it to the machine learning models as well.
Okay. And if you say that as a multimodal psychological signals, so how in your model where you
Yeah.
consider that?
Can you come again, ma'am? Like,
You as a it is a multimodal psychological signal, right?
hmm,
Okay.
yes, ma'am.
So in your model, where you considering that particular signal in what sense?
If you ask like that, multimodal, we are using two different datas, EEG and eye gaze data. So basically, these are we can separate as signal levels, feature levels, and which will be used for decision making.
Okay. So you
Yeah,
directly differentiate at the start of this that particular data. Okay. Yeah.
yeah.
Yes. Okay. Thank you. Fine. That's all from my side.
Thank you, ma'am.
Next topic. Yes.
Thank you.
Thank you, sir, for your presentation.
Thank you. Thank you, ma'am.
So the next presenter is Sakshi Karla from Bennett University, India, and the paper title is Context Aware Hate and Offensive Speech Detection using Hybrid BERT LSTM Architecture. Ma'am, please start with your presentation.
Sure, ma'am. Ma'am, is my screen visible?
Yes.
So, good afternoon, everyone. I am pleased to present our work titled Context Aware Hate and Offensive Speech Detection using a Hybrid Word LSTM Architecture. So, the research was carried out at SCSCT, Bennett University, and focuses on improving automated detection of harmful language on social media platforms. The key idea of this work is to address a very practical challenge: how to accurately distinguish hate speech from offensive language, especially when the text is very short, informal, and context dependent, which is typical of social media content. Right? So now we'll come to the introduction and motivation part. So as we all know that we have many social media platforms, people are giving their comments and citing their posts on many social media platforms like Twitter, Facebook, etc. Right? But social media has two phases. One phase is that that is a good phase, that we can have a good information also, but it helps in spreading. The second thing is that is very bad. There is a fake information is being spread in at a higher rate. So social media has fundamentally changed the way people communicate and express opinions. Platforms such as Twitter, Facebook, Reddit, and YouTube allow rapid information sharing at an unprecedented scale. However, this openness has also enabled the widespread dissemination of hate speech, offensive language, and abusive content. These forms of speech can cause psychological harm as well. It can promote discrimination between the people, and in some extreme cases, it can incite the violence. You have many examples in social media that violence is spread in a high rate through social media. So manual moderation is not feasible in that case, because we have sheer volume of content that is being generated every second. So as a result, platforms increasingly rely on automated moderation systems. So in these days, uh, we can use many machine learning based models. We can use many deep learning based techniques. Basically, transformer models are the state of the art models nowadays. We can use them to detect whether it is a hate speech or offensive. So unfortunately, many existing systems struggle because online language is highly informal, right? So people can write their views in any language, right? So it is so ambiguous and context dependent. So this motivates the need for more robust context aware detection models, right? So one of the most now come to the problem statement. One of the most critical challenges in this domain is differentiating between hate speech and offensive language, right? So there is a difference between two. Hate speech targets individuals or groups based on protected characteristics such as race, religion, gender, or ethnicity, whereas offensive language may involve insults or profanity without targeting a protected group. So there is a difference between the two. So in real world text, the distinction is really explicit. Sarcasm, implicit bias, slang, and cultural context often blur these boundaries. Traditional Traditional machine learning models rely on surface level features and often misclassify such content. Therefore, the central problem we address is designing a system that can accurately model both contextual meaning and sequential dependency in short social media context. Now come to the related work. So there are a few papers that have been published based on detecting the hate speech and offensive language. So first one, so we can see the problem of hate and offensive speech detection has been studied extensively. The problem of hate early work relied on lexicon-based and rule-based approaches, such as the work by Spartus and Warner. They have published their work in 2012. So next is classical machine learning methods introduce feature-based approaches using TF-IDF combined with classifiers like SVM and XGBoost, as shown in Davidson et al. While these models improve performance, they treated text as unordered features and ignored semantics. So this is the main shortcoming of using the classical machine learning model, that they treat the text as unordered features and ignore semantics, means not the structural one, right? So deep learning approaches have tried to overcome these problems, including convolution neural networks and long short-term memories. These are the neural network based architecture based, and they enabled representation learning directly from text as demonstrated by Kim and Bajjati et al. However, these models struggled with long range contextual understanding. Now coming to the transformer based models, these are the cutting edge techniques that has been used in nowadays, particularly BERT, bidirectional encoder representation from text transformers, introduced deep bidirectional contextual embeddings and significantly improved results. In 2018, BERT was introduced, right? And they basically try to get the context in both the directions, right? More recent work has explored hybrid architecture such as combining BERT with LSTM, which inspired our approach and motivated the proposed BERT LSTM model. Now, coming to the proposed methodology, to overcome these limitations, we propose a hybrid BERT LSTM architecture. The motivation behind this design is simple but effective. BERT excels at capturing contextual meaning, while LSTM, that is long short-term memory networks, these are basically the recurrent neural networks, and they are well suited for modeling sequential patterns. Right? By integrating these two components, we aim to leverage the strengths of both architectures. This hybrid approach allows the model to understand not only what words mean in context, but also how meaning evolves across a sentence. Right? So this hybrid approach, it helps in allowing the model to understand the full context in both the directions, right? So each input tweet is first processed using a BERT word piece tokenizer, which is effective for handling slang, misspellings, and rare words. The tokenized input is passed through a pre-trained BERT-based uncased model, which generates 768 dimensional contextual embeddings for each token. Right, vectors, we are converting the words into the vectors now. These embeddings are then fed into the bidirectional LSTM with 128 hidden units, or we can say neurons, allowing the model to learn dependencies in both forward and backward directions. So our dropout layer, which with the rate of 0.3 is applied to reduce overfitting. So there is a problem of overfitting while training the model. When we have training error is less and testing error is more. So this is the problem is called the overfitting. So dropout layer we can use with a rate of 0.3 to overcome this problem. Finally, a dense layer followed by a softmax activation function performs classification into hate, offensive, and neural categories. We have multi-class classification. We can use the softmax activation function with a dense layer, right? So dataset we used, there's a benchmark dataset. You evaluate our approach on benchmark with a dataset commonly used in hate speech research. So the dataset mainly contains three classes. First one is the hate speech, second one is the offensive language, third one is the neutral content. So it reflects the real world challenges such as short text length, informal syntax, slang, emojis, and class imbalance. So data was the class imbalance. So these
Ma'am,
are the challenges.
sorry for the interruption, but we're past the presentation time. Please get to the conclusion.
Get to the conclusion. So can I discuss the
Yes.
results? So these models have been
Yes.
used by, okay,
Yes.
so BART LSTM is giving the best accuracy out of all. So in conclusion, this work demonstrates that context-aware hybrid architectures are essential for accurate hate and offensive speech detection. The proposed BERT LSTM model effectively bridges the gap between the contextual understanding and sequential modeling. The future direction include extending this approach to multilingual and cross-lingual datasets, exploring zero-shot learning, and integrating explainable AI techniques as well to improve transparency and trustworthiness in real-world deployments. So thank you very much for your attention. So these are the references. So I would be happy. So thank you very much.
Uh, Thank you. Now, I want to just understand related to your data set. Basically, your topic is great. I understood the what are the different categories that you have, and definitely BERT and LSTM is work in this particular case. And you said the
Yes.
hybrid approach. So I want to understand what exactly the hybrid approach, which means what exactly you deal with the both algorithms, and
Mm,
related to your data collections, first of all.
so, ma'am, both have their own advantages. Like BERT excels at
Hmm.
capturing the contextual meaning, and LSTM networks
Hmm.
are well suited for modeling sequential patterns. So, by integrating these two components, we aim to leverage the strengths of both architectures. So, in our architecture, first our input tweet, that is in the form of text, is first pre-processed from using BERT's word piece tokenizer, which is effective for handling slang, misspellings, and rare words. Then this token is output is passed through a pre-trained BERT-based uncased model, which also generates 768 dimensional contextual embeddings for each token. Then these embeddings to get the leverage advantages from bidirectional LSTM is passed through the one using by LSTM layer with 128 hidden units. So it allows the model to learn dependencies in both forward and backward directions. So this is the hybrid approach that we are passing our inputs in both using BERT model and LSTM also. Getting the
So,
good feature extraction, getting the good accuracy then.
okay, so in this particular case, whether your offensive speech detection, whatever you have, that is going to be identified using this hybrid LSTM model.
Yes, ma'am. Actually, these are the three classes: hate speech, offensive, and neutral. So using these models, hybrid approach, we are getting the accuracy like you can see from BERT LSTM accuracy 92.1% overall accuracy.
Okay,
Getting.
so can you have any ethical challenges that is associated with your offensive speech detection system?
No, not ethical challenges, but dataset was the problem. Like dataset was
Yeah.
imbalanced. It has short text length. So if we can improve our accuracy using other dataset as well, but using the same technique. In future, we can use that.
Okay, fine. That's all on my friend from my side.
Okay,
Thank
thank you
you.
so much. Thank you so much.
Thank you, ma'am. Now we will go on to the next presenter.
Thank you. Thank you.
The next presenter is Hari Zadav from Vishwakarma Institute of Technology, and the paper title is Energy Harvesting Using Xioelectric Plates for RFID Applications. Sir, please start with your presentation.
Yes, sir. A minute, please. Hello, can you hear me?
Yes, sir, you can start.
Yeah, okay. So the topic for today is energy harvesting using piezoelectric plates for RFID application. So getting to the introduction. So global energy demand is increasing, as we all know. So for that there is a demand. For that there is a need for creating sustainable micro power sources. Herein, mechanical energy from footsteps and vibrations is abundant, but it is largely unused. Like it every day thousands or maybe lakhs of footsteps are there are lakhs of footsteps, and but there is the energy which is used, which is created from the footsteps is of no use, like it is not used anywhere. So this is where piezoelectric plates come into action. Piezoelectric energy harvesting converts the mechanical energy from the footsteps into electrical energy. It is ideal for applications for in case of battery replacement, such as wireless sensors, wearables, etc. The problem statement. The conventional battery parts systems, they require frequent replacement, such as high maintenance and environmental impacts. For that, large amount of energy is mechanical energy is generated from human footsteps, but it is of no use. Everything is unused. Existing piezoelectrical energy harvesting suffers from low power input, poor efficiency, and limited practical development. So this is where our problem statement, our solution comes into action. There is a need for a low cost, reliable, and smart energy harvesting system that can convert footsteps energy into manageable energy. Next. So the background of the study, this was the background. First, it was about the wireless sensors, the IoT devices, anything and everything electrical device which can be used and which can be which anything and every electrical device which can be used with the help of energy with which demands low power is our solution in here. Next. So our solution. So what there are three concept topics which we have covered. First is low cost design. It is to develop an affordable footstep energy harvesting system. And second is efficiency. It's to generate and store the energy which is generated from the footsteps in a battery. And third is using RFID, so that RFID implementation, so that there is a secure energy access. So this is our flow diagram. As talking from the left, first there is mechanical stress which is put by the footsteps. This mechanical stress is stored is taken by the piezoelectric plates, which amplifies the energy and stores in a battery or any rectification system. Also, in between this, it is converted from AC to DC. The mechanical energy which we get from footsteps is an AC, uh, alternating current, which is converted into direct current. Now from here, the Arduino is connected, which keeps everything in action. From where charging and discharging can take place. Simultaneously, there is voltage regulator and also LCD display. From which if we want to display anything or if we want to regulate the voltage and use it anywhere with the help of USB port, we can do that. Next. So these are experimental. These were our experimental setup in which we took 10 piezoelectric discs and connected them in parallel to increase the current. So there were test subjects. There were uh, per people from 50 to 60 kgs of weight range. Each performed almost close to 100 footsteps, and we measured that using Arduino and digital multimeter. Next, system architecture. So this overview. So what was used was first piezoelectric disc each of 35 mm, then Arduino Uno, then rectifier and capacitor to convert the AC to DC, the AC current to DC current, and capacitor for smoothing, and then amplifier to amplify the current, battery, RFID module, and all, and acrylic sheet to support the structure. Yes. So this is the system overview in which first a footstep-based present in a charging system is proposed as it converts mechanical to electrical energy. Then multiple piezoelectric discs are used to handle the weight, to handle the balance, and they are connected in parallel to increase the current output. Then AC voltage is generated, which is conditioned using an amplifier, and then bridge rectifier converts AC to DC for DC, and a battery is used to store. So this is our control storage and application. As I said, it is stored in a rechargeable battery which can be used further. Like the Arduino Uno, microcontroller which we have used, it can uh, power that, and also the relay module. And the relay module here is used to control the charging and discharging. Also, the RFID module is used to secure and such that no unwanted or unrestricted use of energy takes place. This is the working principle. Next. So this here is the mathematical modeling in which we have calculated energy using the given formula. We have taken a sample data range for 50 kg and for 60 kg weighted per people. Here E is equals to W into G into D, and thus the mechanical energy is we get the output as mechanical energy. Then the electrical power and uh, total energy harvested we get that as the solution. Also, uh, results and discussions. Talking about the results and discussion, here the proposed system evaluates the relationship between the applied body weight and the electrical output which we get from the footsteps. Experimental results here shows a near almost close to linear graph in voltage and power output with increasing weight such that they are directly proportional. Also, the first we can see two graphs. First is weight versus voltage, and second is weight versus power output. It shows a near linear graph. The graph here shown is for sample, but in when we check in reality, it showed an almost near linear graph. These are the limitations and future
Hello.
scope. In the future,
Sir, sorry for
yes,
the interruption, but we are past the presentation time. Can you please get to the conclusion?
yeah, conclusion. So this is the conclusion. The piezoelectric footstep energy, which is harvested, it is a feasible method for converting human footsteps and other mechanical energy to electrical energy. Also, the RFID which was used, it enhances the security and usability. It also supports micro energy generation for low power applications. And the approach which we have used here is suitable for IoT devices, then any smart wearable or in the infrastructure development. Thank you. Any questions?
Thank you, sir, for your presentation. If there aren't any questions, then we can move forward with the next presenter.
Yeah, sorry. One moment. Am I audible, hopefully?
Yes.
Yes.
So, yeah, my first question is related to that. What are the challenges might arise while you're deploying the system? Have you deployed, first
So,
of all, the system in real-time environment?
no, we have not deployed it. We have used as a test case. There is a prototype which we have used. We have not deployed it.
Okay. And what is the estimated cost per unit? And how does it support to claim your cost is being low cost?
Like looking at the existing energy, like looking at the
Mm-hmm.
existing technology which is worked on this, there are multiple, like we can say, like there are multiple companies which are working on it. And as long as my research says, they also created such prototypes, but their cost was much, like too much. And talking about ours, we created this sample prototype in less than 2,000 rupees, like around 1,600 to 1,700 was our total cost for including everything, like the piezo plates, then Arduino Uno, and all that. We have used
Okay.
20 piezo plates for that of 35 each.
Okay. Last question. Can the system will be integrated in future with the IoT smart grid application?
Yeah, we can integrate it further. I want to say that here, whatever energy we can uh, generate from this, we can integrate with any sort of low energy devices, like which takes low energy, like for example, phone charging or any IoT devices as you mentioned, we can use for that.
Okay, fine. That's all from my side. Siddhi, over to you.
Thank
Okay, ma'am. Now the next presenter is uh, Gujula Ramya from Valurupalli Nageswara Rao Vignana Jyoti Institute of Engineering and Technology. And the paper title is Reconfigurable Intelligent Surface Assisted Vehicular and IoT Communications, System Modeling and Performance Analysis. Ma'am, please start with your presentation.
Yeah, hi. Hope I'm audible.
Yes.
Okay, let me just share the screen. Is my screen visible?
Yes, ma'am.
Okay, thank you for the confirmation. So already we know that there's a lot of research going on in the present scenarios, which is like 5G and 6G. So in order to uh, reach the data rate and the throughput, which is very, very high nowadays in a time varying channel along with the high Doppler situations. So I just want to understand how the user is moving and what is the data rate we can supply to that and what is the speed, and we have many different parameters to be considered. So one of this is a vehicular and reconfigurable intelligent surface is what we are trying to assist with IoT and the vehicular. Or still we have many existing architectures which cannot sustain this 60 requirements, even though in convergence towards with the fundamental issues. The necessity technology now we are trying to influence in order to adapt it to the propagation environment now. So everything in this particular research is all about fulfilling the 60 requirements using this RIS. So why RIS? So we are having a parallel research which is going on ISAC also, integrated sensing and communication. So how RIS is helping us with this random shift in the wireless connectivity. So RAS structures can enhance this desired paths and also suppress the unwanted ones and effectively shape the channel. This is what which makes us use this particular technique. And the position of RASs are always a cornerstone technology for scalability, which increases the energy efficiency of a 6G network. And also which will have a maximum and coverage improvement and with low cost and scalability. All these three will give us a high recommendation to go for IRS when compared to all other parallel researches going on. And the major research back gap is the same thing. We need a unified model for this. Although we still have a prior investigation into RAS systems, primarily we need to examine the isolated scenarios. Many time varying channel scenarios need to be considered. Then a continuous phase shift where the commercial RAS hardware operates under discrete quantizations. So this our study addresses all these gaps by presenting a complete modeled framework, integrating the practical constraints which we are trying to take from a real-time channel and delivering analytical and simulation performance analysis. These are some of the core contributions of the particular research. There are five different core contributions which are out from this research. One is a full stack system modeling, how the user equipment base station are communicated with the help of RIS, and a closed form of performance metrics. So some parameters which we looked into were SNR, BER, and achievable rate. And then the phase optimization. So how the phase is being shifted from one particular path to the multi paths which are being communicated between the base station and the user equipments, whether it is a stationed or moving. And then we have simulated some practical and theoretical models, then comparison between all the simulations which we have done. So this is a complete contribution of the research. Here comes the system architecture, the base station, user equipment, which is aligned with the RIS. RIS is nothing but a reflecting elements which can be placed at any point of time in the particular channel, which will help us to regain the multi paths which are being transmitted between the base station and the user equipments. Always the signal has uses this RIS as an intermediate repeater so that it transfers the data from base station to the user. That's how the data flow happens in the particular system. Then comes the channel modeling. These are the mathematical expression which the channel is undergoing and the corresponding output expression. Direct link is what which we have considered as for the simulations. Then followed with the phase shift optimization. So when we are having more than one path to make a communication, we need to look into the phase shift, which is very primary and important. So that is what the one of the constraint which is optimized. With the help of that, phase optimization is also simulated with a mathematical and analytical model. Along with the phase comes in to the picture the mobility and the Doppler. Because the vehicles are moving, once a vehicle is moving, we need to consider the velocity of it and the speed of it. Even those two are considered, which is a dynamic challenge to be incorporated into the research work. As we are completely researching on the vehicular things and IoT, high mobility is which is the constraint which we are trying to focus on more. After the particular simulations, we can just conclude based upon the achievable rate, indicating the throughput potential from the Shannon theory, and BER under QPSK modulation, capturing the link level reliability. And the third benchmark was the outage probability, which is qualifying how frequently the system fails to meet the minimum rate threshold. So together from all these multidimensional pictures, we were trying to figure out that RIS were very effective. These are the three things which we looked into. From the simulation parameters, some of the predefined simulation parameters, and the channel model used is relay and Raytheon. So this is the particular simulation result. Achievable rate with the top spectral efficiency is being considered, where RIS boosts throughput, vehicular system higher rate with higher SNRs, and the stable performance at low SNR, which is exactly needed for a proper communication system. And now I can conclude by saying the overarching conclusion is that RIS is markable improves with both reliable and spectrum efficiency in diverse communication constants. So it performance holds even under the quantized control, making it as a paramic solution. So futures research will also explore into this integration of RIS with ISAC, which will have a developed and mobility aware algorithms and experimentally validation to the hardware prototypes and the field things. By here, I conclude that thank you for your attention, and I'm also welcome to take any questions regarding the modeling assumptions
Okay.
or the
Uh,
optimization work. Even the one of other scholars is also available of the same research work. We are here to address you.
uh, Thank you. Nice presentation. Just I want to understand where can RIS can be practically deployed in the real world vehicular network.
Any in
Can you provide any real-time example? Actually, I want to
Yes,
understand.
madam. Already we have power poles in our cities, right?
Hmm.
So any building can also be taken as a base. You can deploy your RIS on any building or any traffic light. We are actually trying this in our college. We have the procure the hardware equipment. So we are trying to
Okay.
place it somewhere in the parking area. So our college is of uh, 3 to 5 acres. So when we are trying to transmit from one particular lab to the gate, so when and the parking area is
Hmm.
what where we try to park all the vehicles. The vehicles are the users, and the base station is somewhere available at the principal office. And we are trying to place this particular RIS somewhere in the middle of it. It's just under process,
Oh,
but we are just going on it.
okay. One more thing. How does your RIS align with the 6G communication vision?
High mobility 60 communication is no what
Mm-hmm.
it is trying to take the time varying channels into the picture. Time varying
Okay.
channel, we should read the estimation of a time varying channel. So now as the vehicular movements are always moving with the time, the channel which we consider it
Mm-hmm.
is into the 6G.
Okay. If suppose RIS hardware fails, so how does it impact the communication system?
Okay, if the hardware is fail, it's like mirroring, right? We are not using only one particular hardware. We might be
Okay.
using two or three or five. So one repeater is failed, we have other repeater which comes into the picture very immediately.
Okay. Fine.
It,
Thank you. That's all from my side.
thank you, madam.
Yeah.
So the next presenter is CP Sri Ramya from Dayananda Sagar College of Engineering, and the paper title is Signal Reconstruction of the EEG Signal using Python with the help of Comprehensive Sensing and OMP. Ma'am, please start with your presentation.
Thank you. I will share the screen now.
Yes.
Is the screen visible?
Yes, ma'am. Just share your PPT. We can see the Zoom tab.
Is it visible now?
Yes, it is visible now.
Good morning, everyone. I am Sri Ramya from the Department of Electronics and Telecommunication Engineering, Dayanand Sagar College of Engineering. Today, I'll be presenting our paper titled Signal Reconstruction of EEG Signal using Python with the help of compressive sensing and orthogonal matching pursuit. This work focuses on improving EEG signal quality when the data is incomplete or noisy. As we all know, EEG signals are widely used in medical diagnosis, especially for conditions such as epilepsy, sleep disorder, and cognitive analysis. However, EEG signals are highly sensitive to noise and data loss due to the sensor limitation or transmission issues. Due to this, accurate analysis becomes difficult when signal is corrupted or partially missing. This is where signal reconstruction comes into picture. As we all know, signal reconstruction is the process of recovering continuous time signals from discrete samples. Accurate EEG signal reconstruction uh, improves the clarity of the signal, thereby aiding in diagnosis. Next, I will be telling about the objectives of this project. The project aims to streamline EEG data acquisition for efficiency and improve accuracy of the reconstructed EEG signal. And then we also aim to reduce the noise as well as improve the speed of EEG signal reconstruction. Next, I'll be talking about the literature survey. There are several research on signal reconstruction using compressive sensing and sparse recovery techniques. The existing studies have applied compressive sensing approaches as well as modified OMP orthogonal matching pursuit approaches, as well as basis pursuits and gradient based pursuit algorithms. While these approaches have achieved reasonable reconstruction, they often face challenges related to computational complexity, noise sensitivity, or reduced performance at low SNR ratios. This limitation motivates the need for more efficient and robust reconstruction framework, which we address in this work. Next, I will be explaining about methodology that is used for reconstructing the EEG signal. We first apply wavelet transformation to convert the EEG signal into a sparse representation, capturing both low and high frequency component. The sparsity is essential for compressive sensing. Next, we apply compressive sensing techniques where the EEG signal is acquired using few measurements by exploiting the sparsity, thereby reducing the data storage and acquisition requirement. After applying compressive sensing, then we apply orthogonal matching pursuit algorithms. This algorithm is a greedy algorithm which iteratively selects the best matching components for to approximate the EEG signal efficiently. After applying OMP, we apply Bayesian refinement technique. This is applied to improve the accuracy of the reconstructed signal, and then we apply adaptive thresholding techniques to remove the residual noise, ensuring the reconstructed signal is clean and reliable for analysis. This is the flowchart of the project, wherein we initially select an EEG signal data set of a subject performing different tasks. The data set is in the format of EDF file. It's a standard format file for storing and exchanging medical time serial data, particularly EEG data. When we use Python to convert this file into a CSV file with the help of MNE library. This data is then used as the EEG data. Here, as we know, EEG data is of multiple channels. Here, we're only selecting a single channel for testing. We then perform wavelet transformation to convert the multi-volt data signal into a sparse data signal representation by capturing high and low frequency components of the EEG signal. After, after wavelet transformation, we generate a Gaussian sensing matrix, and then we multiply this matrix with the coefficients of the wavelet transformation of the EEG signal. The product obtained from this is then used as as one of the inputs for the OMP algorithm. The output of the OMP algorithm, along with the products of the sensing matrix and the coefficients of the wavelet transformation, is taken as input for the Bayesian refinement function. This function reconstructs the signal completely, and then we apply adaptive thresholding. Through this, we obtain a clear and clean reconstructed EEG signal. Then we plot the signal using Matplotlib library, and we calculate the mean square error as well as the signal to noise ratio, noise persistence. Through this calculation, we validate whether the EEG signal is reconstructed properly or not. These are the results obtained through after performing the above steps mentioned. Here, the data set we have used is a person performing a motor function. The first plot is the original EEG signal. The second plot is the reconstructed EEG signal. And the third plot is the comparison between the both original and the reconstructed signal. This image is the output that we obtained in the terminal, which specifies the number of samples that we have taken and the wavelet coefficients that are generated after wavelet transformation. And it also specifies the mean square error that is obtained. As we can see, the mean square error is a very less number, which indicates that the reconstructed signal is of high accuracy. We also see the SNR value, which shows that which is
Hello.
a higher value here.
Ma'am,
Which
sorry
show
for the interruption, but we are past the presentation time. Can you please get to the conclusion?
Yes. As you can see, the SNR is little higher, which shows that there's less amount of noise in the reconstructed signal. Here we have taken the data set of a person performing a mathematical operation mentally. Here also we observe that the mean square error is less and the SNR is high, showing that it is accurately reconstructed as well as there's less noise. The applications of this is that it improves diagnosis by enhancing EEG signal quality. It aids in research by isolating specific brain activity, and it enhances detection of epilepsy, seizures, and sleep disorders. Thank you. I am open for questions now.
Can you please go ahead with your system architecture?
I did not get you.
Yeah. So I would just want to understand really your OMP and Bison refinement. Why it is necessary?
We are using OMP to reduce the time that is taken for reconstruction of the EEG signal. And we are using Bayesian refinement to enhance the accuracy of the reconstruction. Adaptive thresholding is to reduce the residual noise that is present in the EEG signal.
Okay. Fine. Rest of the thing is good. Thank you.
Thank you.
Yeah. Over to you.
Thank you, ma'am. Now we will go on to the next presenter. So the next presentation is by Vishali Agarwal from Punjabi University, and the paper title is Simulation Driven Analysis of Blockchain Protocols and Smart Contract Using Remix IDE. Ma'am, please start with your presentation.
Yes. Good afternoon, everyone. Let me share my screen. Am I audible?
Yes.
Is my screen visible?
Yes, ma'am.
Okay, yeah. So my research topic is simulation-driven analysis of blockchain protocols and smart contracts using Remix IDE. So the idea is to develop the Remix IDE not just as a prototype, but as a base model for testing the smart contracts. So starting with the blockchain, in today's world, blockchain is everywhere. Like it offers decentralization, transparency, and security. So considering these features, it has come in every aspect. Like blockchain has been used in supply chains for the currencies exchanges in the form of cryptocurrencies, for the contracts. There comes the smart contracts which gets executed automatically. So here the challenges which are there are the a huge gas fee. We can call it as a execution fee that is measured in the form of WEI. The tax are there, so they are the main challenges. Then there is a need of controlled and simulation based testing, so that is why we are addressing the Remix IDE. So it provides the easy compilation, debugging, and simulation. So our main goals are to check the performance of this IDE, and along with that we want to incorporate the smart contracts. So these are the research objectives: establish a controlled environment using Remix IDE, then analyze the smart contracts like ERC20, e-voting, escrow. So these are the famous smart contracts which are there in the market. Identify vulnerabilities using the simulation, then propose a methodology for academic research, provide insights to improve blockchain reliability. So while considering the literature, there are main protocols which are there, that is proof of work, proof of stake, then the other consensus models. So proof of work mainly works on the computational puzzles that the user has to guess one nonce value, and then his work gets you know uh, validated. Then proof of stake, it works on the computational, not the work, but the sources or the share that has been taken by the user. Then the other consensus models are fault tolerance, that is PBFT, practical Byzantine fault tolerance, and then hybrid proof of work and proof of stake models are there. So these are the consensus models that are used in blockchain. Next are the smart contracts. So they were first conceptualized by Nick Szabo, and nowadays they have been used in finance, like in the form of token exchanges, uh, in the form of or we can say fungible tokens, and escrow mechanisms. In governance, they are used as decentralized voting mechanism. In healthcare, the smart contracts are used to secure the patient data. For example, the patient history will be saved, and whenever the patient visits any hospital, the hospital can access the patient history using that smart contract. Then the supply chain, to bring the transparency in the logistics and traceability of goods. So main challenges of smart contracts are security vulnerabilities are there, the re-entrancy attacks and unchecked exceptions and integer overflows are there, the gas efficiency, and that is the high cost of transactions are there. Then there is no standard compliance related to the smart contracts. Next is the testing limitations are there. So we are mainly addressing the testing limitations, the availability of testness where we can directly deploy the smart contracts is very less. Next are the simulation environments for the blockchain research. So a few environments are there. First of all is Truffle Suite and Ganache is there, which provides the local Ethereum blockchain environments, but they require a significant setup and are oriented towards the developers rather than the researchers. So it's a high-end project that for this we'll have to have a large hardware to deploy the smart contracts. Then Hyperledger Caliper is there, which is focused on benchmarking blockchain platforms, but it lacks the granular analysis of smart contract vulnerabilities. Then is Ethereum Remix IDE. It is a browser-based IDE offering compilation, debugging, and deployment in simulated Ethereum virtual machine, that is EVM environments. So main advantages of this Remix IDE are it is easier to use. It uh, it provides the integrated security analysis plugins, and uh, it is not just a prototype but nearly a practical implementation of the smart contract. So the main research gaps that have been identified are the limited simulation research. So most blockchain studies and analyze protocols in real or test networks, like the consensus mechanisms or the attacks. But the systematic simulation driven validation frameworks, they are underexplored. Next are the insufficient smart contract testing. Vulnerabilities, they are documented, the attacks and the other you know uh, lags are there, but the academic research, it really integrates the controlled simulations to identify security and efficiency issues. The security issues are there, but related to the simulations, the research is very less. Then the lack of academic utilization of Remix IDE. Although widely used by the developers, Remix IDE has been underutilized in academic contexts for structured analysis and comparative studies. So, the main contributions of this research are positioning Ethereum Remix IDE as the academic simulation platform, then providing a methodological framework for evaluating smart contracts across the performance, security, and compliance dimensions.
Hello,
Demonstrating,
ma'am.
yes, ma'am.
Sorry for the interruption, but we are past the presentation time. Can you please get to the conclusion?
Yeah, sure. So we used mm, this environmental setup has been used. The Solidity language was used to write the smart contracts, and JavaScript virtual machine was used. And these tokens were implemented on the Remix IDE. And these simulation parameters were analyzed, the gas usage, the execution cost, and latency, and the security aspects which were tested were re-entrancy, overflow, and fallback issues. So these were the metrics that were considered: gas, execution time, and scalability; for the security, attack resistance, and error handling; for reliability, consistency, determinism, standard compliance. So main results were the gas efficiency. ERC20 functions, they are showing varying gas usage, and the optimized compilation, it reduces gas usage by 18%. So the re-entrancy attacks, they are there on the insecure contracts, and overflow tests emphasize the need of the safe mathematical computation. So the main lags of Remix ID, they are no large scale or consensus simulation which has been developed over there, and they cannot simulate network latency and minor behavior. For example, the miner is not honest, that cannot be detected over the Remix IDE. And the another one is limited scalability testing. So the conclusion is Remix IDE is effective for simulation-driven smart contract analysis. It supports gas profiling, vulnerability detection, compliance checks. It is limited in scalability and consensus testing. So in future, we can integrate the Ganache and Caliper with the Remix, and cross-chain simulation can also be performed. AI-based vulnerability analysis can be done, and curriculum development for blockchain education. For these things, the Remix IDE can be used. So that's all from my side. Thank you, ma'am.
Okay, thank you. My question is that what are the different environment available for deployment in Remix IDE?
Yes, ma'am. We can, for acquiring the testnets, we can use the Rinkby and Goerli testnets. They provide us with the faucets. The faucet is like the fake currency for which will be used to deploy the contracts.
Okay, and how does your Remix support the learning versus the production deployment?
Sorry, ma'am. Can you please come again?
How does your Remix support learning versus productive or production deployment?
Ma'am, right now Remix is mainly used as a prototype, but we are proposing that if we incorporate uh, more smart contracts, so it can be used as a real world application as well to deploy the contracts.
So, how does your Remix ID contribute to the growth of the Ethereum developer ecosystem? How you think?
Ma'am, it is channelizing the you know deployment of smart contracts. It is channelizing the deployment of ethernets over the test nets, and we can enhance that to the real networks as well. So that is the main contribution of Remix ID, and along with that, it is using the Solidity language, which is used in the Ethereum. So it is providing the direct link to the Ethereum.
That's all now from my side. Thank you.
Okay, thank you so much.
Thank you, ma'am, for your presentation.
Okay, thank you.
Now, I would like to announce the name of a few participants who I believe are not present in the meeting. But if any of the co-authors are present, they can do the presentation on their behalf. So first is Arif Khan from Jamia Hamdard University. If any of the co-authors of this participant is present, then they can give the presentation. And second is Mukesh Kadu from Datta Mega Higher Education and Research. Okay, so I believe these people are not present in the meeting, so we are done with all of our presentations. So I sincerely thank our authors for their excellent presentations and contributions in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. On behalf of the whole team, thank you for your support during the 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2026. All the presenters would be getting their digital certificates via email within 2 working days, and the publication will be live within 7 to 8 months. Kindly cooperate with the team of ICTCS. I also thank our session chair, Professor Kalyani Ghuge, for chairing this session. A token of appreciation to the chair on behalf of Team ICTCS and Global Knowledge Research Foundation and partners. Thank you very much, ma'am, for your valuable presence.
Thank you. Thank you so much.
Now, before ending this session, I request all of you to please turn on your camera so that I can take a quick snapshot of this conference. For a few seconds so that everyone turns on their camera. Okay, I've taken the snapshot. This was a great session. Thank you, everyone. You can leave the meeting now.
Thank you all. Thank you.